Hello there, welcome back guys, and in today's we are in business, so we're finally adding some lines of code by entering some ladder logic. So stay with me and let's just do this together. Hello there, so I'm Roberto Cruz and welcome back to RTFM guys, and finally, today is the icing on the cake. So just a quick recap before we start these wonderful videos. So we are going through the quick start steps on the help file on the Studio 5000 Logix Designer. So we've already went through on how to create a new project, how to configure I/O modules, how to enter in new tags, data types, aliases. In today's video, we're going to be actually programming the PLC. Very simple. We're just getting familiar to the tool, to the Studio 5000 Logix Designer. So this is the nice one, so we can see how we can program. And I'm going to show you guys various ways of adding, instructions to your ladder logic, and how you can monitoring them, how you can verify to make sure they are obviously correct, to make sure that there are no errors. I'm going to go through how some of the naming convention, what are routines, subroutines, instructions, right, and rungs and all the rest of it. So, all right, guys, just before we just switch screens. So, guys, I'm always obviously updating you guys on new videos on our Instagram page. So make sure you follow us on our Instagram. So the link's going to be in the description of this video. But it's a simple one. It's at RTF_M on Instagram, so you can engage. You can just DM me, so always reply. All right, guys. Okay, so just without further ado, let's just dive into the content. Let me just switch screen, and we're gonna go through again. So I'm always gonna be using the same, same revision, same software that we've been configuring together. So I'm gonna leave here a link. So I'm gonna place a card on these videos so you guys can access the playlist. We're making a whole playlist on Studio 5000 Logix Designer. So you can check out all the previous videos that I just mentioned on the recap. All right. Okay, guys. So here we go. Let's just go through some of the bits and pieces. All right. So entering ladder logic. So ladder logic is the most used programming language. Obviously, we've got 5 of them. Well known nowadays, based on the IEC 61131. If I am saying correctly. Leave in the comments below if I've made a mistake on it. I think it's IEC 61131, which obviously is the standard for PLC programming languages, which obviously has got statement lists, ladder logic, function block, sequential function chart, SFC, and there's another one, structured text. All right, so those 5 languages. But again, I would say that maybe 80 to 90% of all the languages used are still ladder logic, because obviously it comes from the electricity, from the electrical side of things. So an electrician can actually read through for maintenance purposes is way easier to obviously understand the program. All right. Okay, guys. Here we go. So quick start ladder logic. So I'm going to show you guys how we can. But just before we do, so I'm just going to show you. So this is a routine I've just created called motor 1. And so we've got our main task, main program, we've got our main subroutine, and this is the actual main subroutine that it's opened up right now. And I've also created a motor routine, which is empty. We're gonna do this together, right? So basically, what's the routine based on the PLC? So a routine is a sequence of logic that is executed as a block. So the main routine is a routine that executes first when the program runs. Subroutines are blocks of logic that are executed in response to another routine and are contained within the main routine. Fault routines are obviously routines that execute when a program fault occurs. All right, so this is a subroutine. So basically, this is a routine, and then you've got a main routine, which normally calls your subroutines. Sometimes they're not special, they're not doing anything special, but there are various reasons for doing this. One of them is housekeeping, so you can just there are cybersecurity involved, there housekeeping. So there is those only by obviously following those two subjects, you already make your program way easier for people to understand. All right. So what I did here, basically on the main subroutine, I'm calling using the instruction called jump to subroutine. So basically my subroutine, my PLC is scanning and calling every time it runs through the main routine, it calls out the motor routine. So the sequence works like it runs through this, as soon as it finds that, run through my motor subroutine, wants the motor subroutine, and it comes back to where it's being called, right? And then run over the next couple of steps. So it's sequential, right? So you start from the main routine, calls the first subroutine, and then as soon as this first subroutine is done, come back, read whether there is another routine, and carries on like that. So this is simple. It's not, it's not rocket science, right? Simple as that. So today we're renting ladder logic. So there are various reasons, various ways of doing this. We're gonna be working on the motor logic ladder, right? First and foremost, the easiest way of adding this is by using your what's this called basically? It's your this toolbox here, right? Or you've got all your instructions. So basically, you can navigate. So you've got your favorites, right? And then you navigate through all the available special tabs with special instructions, right? For example, we've got only for binary, all the binary, for bits, for you to be able to manipulate bits. You've got one, for instance, like let me just time in counter, which is very handy and very broadly used, right? But we'll just go back to the favorites. So basically, you can have, for instance, let's just add a normally. So basically, you double click because we are online. So double click. So this is where is now editable, rank. So what we do now here, I just create a tag, right? And you click that. So if you click on the normally open contact, you can add up a branch, for instance. So I can drag this branch over here. You see that green symbol? So you can close up your branch. So if I select this place and select another normally opened, and then if I select this place and select normally closed, and then I'm finishing off with an output OTE. All right. Here we go. So I've just entered it. I showed you a way of entering logic. There's another way, right? There's actually 3 ways of entering new ladder logic. The one I use most is this is the way. If you get obviously instructions, basically they are composed of mnemonic abbreviation, right? So I said normally open, I said normally close, but obviously the instruction has their mnemonic abbreviation, and you can, by writing them down, you can create them tags. But this comes with experience, so don't worry about using these. But for instance, if I can just write down using mnemonics, I can just create my ladder logic. For example, let's just BST, which is branch start, right? And then on the first branch, I'm using a normally open, which is chick, right? Which is XIC. So next branch, which is NXB, I'm gonna set another, normally open. So this is my first branch, and I'm gonna end it by branch end, which stands for BND, mnemonic BND. And then we have, similar to the ones that we just added, we have a normally close, which is XIO, right? XIO, and then obviously our output, our relay, or is going to be our OT, our output. So if I press enter, you see, so the same way of writing down. It's a bit more complex because you have to obviously absorb, you have to take in all those mnemonics. Don't worry about that. You don't need to know that by heart. It helps. So if you are working with these PLC for a long time like me, you obviously ended up recording this, so you would know by heart. All right. Another way of doing this, let's just delete that, is by push the button insert. So if I push insert button, you see, so that brings you another element. So what I'm gonna do here, so let's just add up a branch, right? Here we go, branch. What I'm doing here now, I select that bit, push insert again. So so you have to know the mnemonics. Well, you don't need to know the mnemonics, but you can navigate through the instructions here. For instance, bit, my normally examine on, right? Let me just I'm gonna call it examine on from now on, right? It's easy to you for us to monitoring ladder logic in the future. But so we're selecting an examine if it's on, whether it's on, and the same one is gonna be here. But now this time, obviously, I'm just gonna write down shake, right? And here we're gonna insert an exceal, right? Examine off, and finally an OTE, which is an output energize. See, brilliant. So I showed you guys 3 ways so you can add new logic, right? New ladder logic. So let's just start addressing them. So first thing we've done is addressing them, right? And this is called rung. So you've got your routine, and now we've got instructions, right? Which is obviously just the mnemonics. So you have a program consists basically of a set of input and output instructions. Input instructions are evaluated by the controller as being true or false when the controller carries out its scan. The controller sets the output instructions to true or false in response. So this is what instruction does. And then you have rungs. So this is the rung, right? So you've got multiple rungs. You can have obviously your program consists of various rungs containing instructions. So the rungs are elements, the composition of elements of ladder logic. Ladder logic is comprised of a set of rungs, and a rung is made up of several components, which are rung number. So we can see the rung number right here. We've got left and right power rails. So you see, so you've got a power rail on your left-hand side and a power rail on your right-hand side. So you've got your rung wire, which is obviously the connections, right? Those are you've got your rung indication. You have rung state indicator. You've also got rung comment, right? Which obviously aids you to identify what this rung is for. What is the rung doing? So for instance, let me just show you guys how you do it. Edit rung comment. Let's just call this RTFM training entering ladder logic, right? Boom. Push that. You see that? So you've got now a rung comment. How useful is that, right? And obviously this is a branch, which is a parallel logic within a rung of a ladder program. So this, we went through all the naming conventions, right? Let's just recap that. Routine, so we went through on how to, what is a routine? What's instructions? What are instructions? What are rungs, right? And what is it? Branches. What are branches, right? So those are important items that we should bear in mind. All right. So let's just program this thing then. Do you remember that on our previous video, right? We create a motor, so which was an alias. So it's still there, right? So if I just you can always browse for the tag. You see, the motor is right here, right? So and then you can just select, and the motor is going to come up. See? But you can also, if you recall, you can also write down, and it's going to filter, and it bring the tag. So check this out. So do you remember that our motor is an alias to our physical, which is in our case the simulate IO, right? So this is the alias. The alias is just a state just underneath. So our motor, we've got our description, which is our conveyor belt, and then this is the actual output card, which is located in slot number 6, output 0. Right, so what we're going to do here now, let's just create a start button for our motor. And we now have a stop button. Simple ladder logic, right? And then our latch, to be able to latch our code, right? We're gonna reuse that motor, right? Here we go. So you see obviously there is an X mark here, right? So we can do, there's a button up here which is the verify button, right? This is the button, see, verify routine. So if I push, see there are 2 error messages. What are those messages telling us? It's basically telling us that the reference tag is undefined. So we've just written down start push button and stop push button, but they don't exist. So basically the controller don't see them. So what we do, right? We just remember that, right click, new tag, right? Here we go. So start button. So what we're going to do, we're going to alias them to our input card again. So we select our input card. So this time right? We're gonna select, let's just select input 0, right? For the start button, push create. We do the same for the stop button. It's going to also be an alias. So let's just select alias, and we select the same element, right? The same element, same dint, but this now is going to be, oh, check this out, guys. You see that as soon as I push that, you see that the 0 is grayed out. It just means that it's being used. So you can obviously you are now unable to select it because now it's an input used. It's a used input, so you can't reuse it, right? As an alias. So you can just select one, and right. Oh, sorry, this is just the we need to select the actual input. Here we go. Sorry, guys. Oh, 1 second. It's not. Let me just write down that manually. Here we go, Boolean, right? It's not selecting, but we do that manually. Here we go. So see now that the X symbol is now gone, and our program has no errors. So if I just run the verify line again, see, complete, no errors. So what we do to accept, right? So you see this button here, finalize all edits in the program, and it's going to write down our program, our new program, into our controller. Let's just do that, accepting. Here we go, guys. We are online and we've got a bit of a code, right? So which is basically a start and stop. So what we do here, if you want to test it, we right click on that and we push toggle. You see there is a shortcut here, Control T, right? Toggle bit. See? Why is he not running? Why is he not running? See? Let's just do it again. Toggle, because this is an actual input. So it's not a memory, right? So if we had a memory, we would be able to drive it, but this is an alias. So in order for you to be able to run this bit, you have to force this, right? Let's just force that on, right? Here we go, force. So the force is active. So now we, hang on a minute. Let's just this, let's just force these with the memory instead, right? Let's just create a new tag. Let's just call this RTFM temp. Just a simple Boolean, right? So this is a new tag, so accept all the changes. Instead of us driving the inputs, we can actually toggle this. Here we go, you see? So now our motor now is on. So basically I'm just obviously using the same, and now I won't be able to drive the stop button, to toggle this stop button, because it's an input, and obviously it's again mirroring the physical input card, right? And all right, guys, so this is how we configure, this is how we create entering. So I showed you guys how to program your PLC now. Just very simple, just a start and stop system, right? So now this is, we're monitoring it. So when you have the highlight green, you know, around the OTE or around the instruction, it means that it's got a value of true. So it's actually true, which means that it's energized. So in this case, your motor would be running. And I can't, unless I force this signal, right? Obviously, it would never stop your input, right? So this is how it works. Okay, guys. So I hope you guys enjoyed this. Obviously, we're gonna be revisiting. We're still got a couple of steps to run through the quick start steps. So I hope you enjoyed this video, guys. Very handy, and we're gonna be obviously. We're going to continue with our quick start steps over the next couple of videos, so we can start, as soon as we're done with that, we're going to be covering the more complex subjects, all right, complex chapters. So thanks again for watching, guys. Obviously, if you do like, you know, the content, please do consider subscribing to our channel. Make sure you ring the bell to get notified about all our latest videos, right? Follow us on Instagram. You know, feel free to add up any comments or you know, write down in the descriptions below. I would be more than happy to respond. And obviously, I always like to cite always RTFM, guys, and I see you guys next time. Thanks for watching.